Oh, hi, team. Thanks for showing up for your learning. Let's take a look at how we can use Desmos to visualize periodic functions. So we might do something like write in sine x, and that looks pretty good. But then the astute among you notice that this has a period of 2 pi. And some of you have written about this in your writing, but I suspect maybe you're copy and pasting from somewhere on the internet because we haven't taught you about measuring angles in terms of pi. Those are radians. And we like to leave a few surprises for grade 12. This is one of the surprises. So you're going to go to your calculator. You're going to move your face if your face happens to be in the way, and you're going to turn it into degrees. Okay, there, we're visualizing sine x. And that's not very useful, is it? It looks kind of like a straight line, and it very nearly is here. And then so others will say, well, I need to zoom out to see more. There it is. What can you see here? You can't see nothing here. It just looks like a straight line. So that's not very useful, is it? I think you'll agree. So what you want to do, this is the skill you want to have with Desmos, is you want to say, I want to see a certain domain of x values. I would like to see maybe up to 720 and maybe as far back as negative 360. So you put those in. And then you're like, but the y values, I only need a very small range because the range of sine is only 1 to negative 1. So the amplitude is 2. So I might put in here like 1.1. Well, actually, no, negative 1.1 and 1.1. There. Now I get a pretty good picture, I think you'll agree, of this function. I can see what it's doing for different values of x. Here's sine. Sine of 0 is 0. And then as we increase the value of the x, which is increase the angle, oh, look at that. Sine 30 is 1/2. Cool. And then up here, sine 90 is 1. Sine, oh my goodness, sine 150 is also a half. Isn't that cool, everyone? That there could be two values of sine for sine x equals 0.5. Not only two, but actually an infinite number. We'll see up here 390. 390 is the same thing as 30 degrees because that's go in a circle once and then add another 30. So that's 390. So these are all the things that you'll see here. And then if I change this to cos x, then I get a nice picture of cosine. And I can also use this to investigate this stuff. Maybe I have an amplitude of like 0.4. Okay, there's my amplitude of 0.4 or 0.6, or an amplitude of 8. Whoa, if I have an amplitude of 8, I need to change not all the values, but just the y values. Just maybe look at like 9 there and negative 9. And there's my amplitude of 8 sinusoidal function. You see it goes from 8 to negative 8. All right. So this is really what I want to show you is this little wrench menu. Use that to adjust your scale so that you can pick an intelligent y value and an intelligent x value to visualize these functions and see what they're doing. Because I think you'll agree that if I zoom right out, I actually can't tell anything about that. There's really like nothing there for me to see. This looks like a squiggly grass. All right. If I then restored this to like 8 and negative 8, then you'll see, well, now I'm just seeing way too much of it. So anyway, I would need to zoom in to see it like that. Anyway, this is me being silly with the scale. You see, you can get the scale all funky, and you don't want the scale all funky. You want the scale chosen for your needs. So choose the scale for your needs up in the wrench menu. Any more questions, hit me up by email. Otherwise, I remain your faithful math servant, Mr. Jennings. And if you got this far in the video, send me the words sarcastic oyster by email, and I'll know you watched the whole video. Bye for now.